Hello and welcome to our next section of mathematical reasoning notes. We're on section 4C. We're going to talk a lot more about investing. Last time we got into compound interest. And compound interest is mostly going to be a thing for most of the questions we're dealing with today. There's going to be a couple exceptions. But the big difference is in the previous section we're making one big principal deposit and then letting the money grow. However, most people don't really have a big sum of money they can just throw in a savings account all at once and let it sit and earn interest. Most people make regular, smaller monthly payments that slowly over time build and earn interest. That's a more realistic way to save for your house or school or retirement, is to make these kind of systematic payments. So the formula here we're dealing with is for systematic savings, where you're making multiple payments. So big important difference here is the use of PMT for payment instead of P for principal. They're both the amount of money we're depositing. The difference is the payment we're going to be depositing systematically. If you're doing it more than once, you're not just making one deposit. You're depositing over months or years. If you keep putting money away over and over again, that's a payment. And that's going to be this formula we're using now versus last time where we had just the one-time deposit and that was the principal. We're still using T for time. We're going to use APR for our compound interest. It's still an annual interest rate. N will be the number of compounds per year as usual. And this formula will tell us how much our money will be worth after a given amount of time if we keep making that systematic deposit. So for example, in this question, we're depositing $80 per month into an account that has an APR of 12%, so that's its interest rate. We want to know how much money will be in the account after 10 years. So the final amount, the accumulated balance, that's going to be how much money. That's going to be A. Our payment, not principal, our payment is the monthly deposit we're making. Our APR is our interest rate. Again, we'll treat this as a decimal, so we'll turn it into 0.12 instead of using the 12% version of it. And then 10 years will be our time. This is deposited monthly, so monthly tells us that this is a n equals 12 because we're doing monthly deposits. So using the formula, you'll find the balance after 10 years. And taking the $80 payment times this big fraction. On the top, we're going to have a couple parentheses. We have this 1 plus APR, which is 0.12, over n, which is 12. Close that. This one has a power with the n, so 12, times time, so times 10. This minus 1, you have to be careful, is not part of the power, so it goes on the outside, so that minus 1. Make sure you close parentheses so everything on the top happens before you divide. On the bottom, we have the APR again, which is 0.12, over n, which is 12. So it's that same ratio, 0.12 over 12 in both these parts, APR over n, APR over n. Really careful about where everything goes parentheses-wise. This one, sometimes the hardest part of this one is just typing in the calculator. It's easy to make a little mistake here or there. Starting this off, I'm going to type the 80 times and then do a double parentheses, put a starting 2 here. 1 plus 0.12 divided by 12. Close that parentheses. Do our power button. And then I'm going to make sure I get this right, so I'm going to put parentheses around the top. Do 12 times 10. Or you can do that multiplication in your head. That one's not too bad, but some of them are hard, so it's good to remember to do parentheses on powers. Here, my calculator, I need to make sure I get out of the power, so we hit the over button before I hit the minus 1. That's a mistake people make, because they get the minus 1 in the power. You don't want it in the power. Close parentheses for the top of the fraction. Do divide by to get ready for the bottom of the fraction. And then parentheses 0.12 divided by 12. So that's how we would type that in. And hopefully that should give us our amount. So this 18,403 is not just the deposits we've made. We've made those $80 deposits, but it's also the interest that they've earned, because every deposit we put in is earning some interest, and it rounds up to 0.10 because of that 5. So we're going to round that to 0.10 to get the nearest penny. So if you just looked at the $80 deposit each month, it wouldn't be this much. This also includes all the interest we've been earning. Every payment, as soon as it gets in there, it starts earning that 12% interest, yearly interest rate, so like 1% per month. that compounds every month, so it grows and grows, and that's why we get up to $18,403. So that's, again, using $80 deposits over 10 years with 12% interest rate. That's how we get this 80,000 monthly compound. Let's do another example of this. So same formula still doing monthly payments. Just to know about these is this formula is actually specifically for the situation where your compounding period is the same as your deposit frequency. So like in the last problem we did monthly, we did, okay, every month you put a deposit in and every month the interest compounds. And that's going to be the most common one. I think it's always true maybe for the homework, but I'll be careful maybe not to say always just in case there is an exception. But because this formula would still work if we had like daily deposits and daily compounding or weekly deposits and weekly compounding. I think it's typically going to be monthly because most people save on a monthly basis. They put a deposit in each month and then you get compound interest. If you need to do a situation where your compounding is different than your deposit frequency, say you're depositing monthly but you're getting continuous compound interest, then you would use a slightly different formula. We're not going to cover that in this class. This will be enough for us for systematic. So we'll just stop with this and use that for systematic. But just so you know, like if you in real world, if you had a situation where you're compounding and your payment, we're having a different rates of time, you would need to use a slightly different formula. But we'll do this one again. Again, we'll probably have n equals 12, so we'll do monthly. So let's see. At age 30, Bill starts making deposits in his IRA. It's an individual retirement account with an APR of 5%, so that's his interest rate. At the end of each month, so he's doing monthly deposits, he deposits $60 in the account. So that's his monthly payment, is $60. How much will his IRA contain when he retires at age 30 or age 65? Compare the amount of total deposits Bill made over the time period. So first we're going to figure out at age 65 from age 30 how much time has passed, but you can just do 65 minus 30 and see that 35 is going to be our time. Our deposits, the PMT is going to be that $60. His APR is going to be 0.05. That's our APR. And again, N is monthly, so N is 12. These are regular monthly deposits. So that's what we used in our formula to get this. So we get A equals payment of $60, single fraction, double parentheses 1 plus APR, which is 0.05, over 12 for N to the 12 times 35 for the power, minus 1, close that parentheses, on the bottom we have that 0.05 over 12. So that formula should give us how much he's going to have after 35 years, so he's making $60 deposits each month, and it's only earning a 5% interest rate. So 60 times, parentheses, 1 plus 0.05, divided by 12, close that parentheses, power, start a new parentheses, 12 times 35. This is where I wouldn't do it in my head, because 12 times 35 is kind of difficult. So it's a little bit better just to type it as a parentheses. Make sure you get out of the power, type minus 1, close parentheses, divide by parentheses 0.05, divide by 12. Okay, that should give us the correct amount. So here we can see that with interest, he's made a decent amount of money. He's actually at $68,165.55. So that's total. That's all his deposits plus all the interest that they've earned. Now, to get an idea of like how much he actually has put in there and how much he's earned in interest, let's figure out his deposits. And to do his deposits, there's no like special formula for this, but it's pretty straightforward to think about and figure out. We know how much he's depositing each month. He's doing $60 for his payment. We know that that's a monthly payment, so he's doing it times 12 times a year, the number of months. And in this case, because he's making this deposit for 35 years, that 65 minus 30, 35 years, you can multiply by that 35 years he's making this deposit. And this will tell us the amount that he actually deposited. It's not really a formula, but it makes sense that we take the monthly payment times the number of months in the year times the number of years, we'll figure out the total he's paid in deposits. So we do 60 times 12 times 35. End up with 25,200. So he actually only deposited 25,200. The rest of this was all interest. So if he had put this in an account that hadn't earned interest, if he just set it in something, like a checking account or a savings account with really poor interest, he would have been pretty close to this amount after the end of 35 years. The 68,000 is, because he put it somewhere that earns interest. So he ends up with another $43,000 because he deposited somewhere that earned interest. If he had been depositing a little bit more, if he had a better interest rate, he could probably have even more money after, 35 years. But this is a pretty good amount. That's more than double what he's actually deposited. So he made more in interest than he actually put away into this account. So a lot of the homework questions will do this. We'll ask you to find, how much is the account worth after the period of time, but also how much was actually deposited. It's a really good comparison. It's really good to see how you deposit a little bit of money, but you make a lot because of those interest payments. It's that compound interest. It's so powerful, and that's what he's using to save. Yeah, there's one more way we can use this formula. So we can use it to plan ahead. Sometimes we don't know necessarily how long we need to save something, or maybe don't know what our payment would be. But we do know what we want to have, what we want our final amount to be. And so we can go back and we can find our payment, especially if you decide how long we have to get that payment. So sometimes we have a savings goal. We want to reach a certain amount for like a down payment on a house or saving up for college expenses for kids. In these situations, we want to find the accumulated balance. We know the accumulated balance. We know the final amount we want. But we don't know the payment. We don't know how much we need to put away each month to get there. So we can use systematic savings plan to find that value. So we're going to use this formula, but instead of knowing the payment and trying to find A, we're going to know A and we're going to find the payment. So you can see in this problem, they say you want to purchase a new car in 5 years, so they know the time frame, their time. Expect the car to cost $32,000. So it's not how much we're going to put away each month. We're not putting $32,000 away each month. That's ridiculous. This is what we want our final amount to be. We know our time. We know how much we want to save up to. Now we know that the other stuff. The bank gives us a guaranteed APR of 5.75%. So maybe some kind of account or some guaranteed level of interest. If you make regular monthly deposits, how much should you deposit to have for your car? So how much should you deposit? This is the big question. This is saying, what is your payment? These are monthly deposits, so N is going to be 12. And I kind of mentioned that N's almost always 12 for these problems using this systematic savings. Again, the big way we know that this is systematic and not stuff we did last time in the last section where we were doing like one deposit is because the deposits continue. We're doing regular monthly deposits. This is not just a one-time principal. This is a payment. We're looking for the payment. We don't know what it is, but we know we have to use this formula anytime that's a regular payment. We do more than once. Okay, so putting in what we know we know the 32,000 is A. Payment is what we're looking for, so we don't know that. We're going to find that. We still know the rest of this stuff. We know that 1 plus APR, which is going to be 0.0575 with the decimal 2 spots, and is 12, so divide by 12. The power of 12 times, in this case, 5 years, minus 1. On the bottom, we still have 0.0575 for APR and 12 for N. So we're going to have to do a little bit of algebra. We're going to have to solve for payment. Now, before we do that, to make our life easier, just like we did in the last section, we're going to take all this stuff and we're going to throw it in a calculator, because if we can put this in a calculator, we'll just get a decimal number, and then that makes it a lot easier to divide across and get payment by itself. So let's take all this stuff and just figure out what that decimal would be. I'm going to do my double parentheses again. 1 plus 0.0575 divided by 12. Close that parentheses, do your power, parentheses, 12 times 5. Again, you could do that, multiply that in your head. So parentheses, you could just do like 60. But I think it's easier just to multiply 12 times 5 in the calculator and not have to do it in my head. Minus 1, close that parentheses. And then, and here's what I was talking about. This is the mistake I like to make, and students like to make this too. If you have a calculator like mine where you get into this little high print like this, where you're doing the power, it's easy to accidentally put the minus 1 in the power, and I don't want that in the power, so I have to make sure I put the right arrow get out of the power, and then type -1 and close your parentheses. Now you can see the difference, how it's not small and up high, it's -1 like this. So now that -1's not part of the power. Divide by, parentheses 0.0575, divide by 12, close that off. So now we've got that number we're dividing by, that 0.0575 divided by 12. All this is just going to give me a decimal. So it's 69.3236. That way I can just have payment times some decimals. So I don't have to type all this stuff in a calculator or like divide it across anything. I guess I did type it in a calculator. So I'm having to use it to do algebra. I'm just going to turn this to a decimal, which is about 69.3236. At that point, there's a 0. That's probably a good spot to round the 2. We can just leave it alone, leave it at 0. So that's pretty close. I like to keep a lot of decimal places when I'm doing this, so that when I go to divide and get my final answer, there's not too much rounding, because too much rounding can cause a wrong final answer when you round before you're done. I rounded, but I rounded pretty far back, so it's probably close enough. I'm not going to lose too much precision. Here I get 69.3236. Divide by that on both sides. 3236. That way I can cancel this guy on this side. So we get payment by itself, so we know that we can find payment. Just by dividing these two, that'll give us the payment. So I'm going to take 32,000. And I'm going to show you that trick again where I'm going to use the 69.3236. It's already in my calculator. So when I hit divide, I'm going to hit second. I'm going to hit this A and S button right here. And it's just divide by this previous answer. So divide by that 69.3236, all that's in my calculator already, giving me kind of the most exact answer. So I get 461.60. I can take that 3 and just round it off. 3 doesn't carry it up, so it's up to 60. So that payment should get me there. If I want to, have a little bit more extra, I can always increase the payment a little bit. But this will be enough that if I have a guaranteed interest rate happen those all 5 years, and if I keep making deposits, $406 each month for 5 years, I will have enough out of the $32,000 that I need for that car cost. So I can kind of plan ahead and I can say, hey, in 5 years I want to buy a nice car, I want to have money for it, so let's put payments away, and then I don't have to pay interest. I actually earn interest on the payments I've been putting away to buy this car. So this is kind of the nice way to do it, where you can save up and go buy the car and say, hey, I have the money, so I don't have to borrow for the car. I'm not paying the bank interest. You just earn interest with the bank. You do have to wait 5 years before you get the car. So if you can do that, that's great. If not, that's why we borrow money for cars. But this would be the other idea. This would be planning ahead. Okay, so this is the systematic savings plan formula. Let's talk a little bit about what you might actually use this to invest in. A lot of people will do things like invest for retirement or for college. They'll put these monthly payments in and they'll use that to save up. Now, what do they invest in? Well, some of the main types of investments include stocks, bonds, and cash investments. Stock, also known as equity. So you hear people talk about shares of equity or equity. That's usually referring to stocks. Sometimes they'll talk about equity in a home. That is different. But equity, a lot of times, is stocks. A stock is a share of ownership in a company. When you buy a stock, when I go out and buy a Walmart stock or an Apple stock, I am buying a part of that company. Now, some of those companies are so big, they have thousands and thousands of shares out there. So even if you go out and buy a whole share, you really don't have enough to be in control of the company. If you want to take over a company, that's one way to do it, is just to buy enough shares. And that's how Elon Musk was taking over Twitter, is you just buy enough shares of the company that he had ownership of the company, and then he could come in, kind of say how things were run. There's actually a lot of legislation rules about how you can buy a company out and requirements and stuff. So that's why there's a lot of legal drama with that stuff, and that he did that too. Stock is bought and sold either for a gain or a loss when the value of the stock grows and it's sold at a gain. So you've actually sold at a higher price than you originally bought it for. That's called a capital gain. The profits from buying and selling stocks are capital gains. Some stocks also pay what's called a dividend. This is just a portion of the company's profits. It's usually written out. They have these things called a stock prospectus, and it explains how the stock works. So certain company stocks will basically have a guarantee that, if they make a profit, then this percentage of that profit goes to their shareholders. So, where basically per share you'll get that amount of money. That usually helps keep their stock prices a little higher because people know that each year they're going to be getting some money in the form of a dividend. There's rules, regulations on those dividends and their profits and stuff like that. But that's another way to make money off stocks. So stocks, you either usually make money by buying them, holding them until they're worth a little bit more, and then selling them at a higher price, or by holding the stocks that pay dividends and just making those, receiving those dividend payments periodically. Those are kind of the two big ways we earn money with stocks. A bond is a form of debt. It's a loan to a company, or it could be a government. Governments can issue bonds as well. Bonds are different, that they pay simple interest. Stocks actually grow with compound interest because the stock company value grows over time. The next month it keeps compounding its growth. Bonds are just paying simple interest. We call that simple interest rate on the bond, called the coupon rate. At the bond's maturity, the bond issuer will pay back the face value to the holder. So for example, a city wants to build a zoo. They need some extra money to do that. They issue bonds. And the bonds, they're like $1,000 bonds, and they mature in 5 years. Then through those 5 years, they'll pay simple interest each year, whatever the rate is on the coupon rate, and then at the maturity, they will, pay back the $1,000. So whoever bought them, will get the $1,000 back, and throughout the years up to the maturity, they've been getting interest payments. So that's how bonds work. There's more variations, there's different ways to do them, but the big thing to know is that they pay simple interest. Bonds pay simple interest. The coupon rate is their interest rate. Maturity is when they pay back the initial investment, which is called the face value. It's the initial price of the bond. So when you buy a bond, you're basically loaning money to someone. It's just a way to loan money. Cash investments, these are money deposited in bank accounts, certificates of deposit called CDs, U.S. Treasury bills. They usually earn a small amount of interest. They're usually fairly secure. Things like CDs and Treasury bills. CDs are usually backed up by banks. U.S. Treasury bills are backed up by the U.S. government. They don't pay a lot of interest because they're really safe. We'll talk about more outcome. That's a thing later. But that's what a cash investment is going to be. These things, like your money in the bank, basically. Not a ownership of a company, not a debt to a company, but just kind of money you're putting aside and saving for a rainy day. There are lots of other types of investments. There's things like real estate. A lot of people invest in buildings, houses, property. Mutual funds, which we'll talk more about later, but they're combinations of stocks, bonds, or either one. ETF, electronically traded funds. Options, annuities, derivatives, commodities, cryptocurrencies, and there's more. Bankers have just found more and more different ways to invest in different things people are doing, and these are some of the ways they do that. Now, when you go to invest, you have to have some big three considerations in your investment. The first one is liquidity. We liquidate an investment when we exchange it for its cash value. So when we sell our stock, or there's actually a secondary market where you can sell bonds, or maybe if you get where you cash in your bond, when you cash in a CD, when you sell your real estate, your property, and you get your money for it, you get the cash out of it. That's called liquidating. Investments some are harder to liquidate than others. It's a lot harder to sell off a $1 million real estate investment than it is to probably sell $1 million in stocks and bonds, because you have to find one person that wants that real estate investment versus you can sell the stocks and bonds to a bunch of different people. So you can break it up a little bit easier. Cash investments are really easy to be liquidated because it's pretty much already cash. So liquidity is how easy it is to liquidate an investment. An investment that can easily be exchanged for cash is called liquid. So something that would be a good example would be, stocks. The stocks are usually easy to unload. You might have to sell them at a little bit of a loss if you want to sell them fast, but they sell pretty quickly because you can find, there's thousands and thousands of people that want to buy stocks. So usually you can find someone to sell your stock. Bank accounts would be really liquid because it's just cash in the bank. So you can spend that easily. You can get your cash out of it really easily. Bad examples, real estate is kind of the worst because it's hard to find someone to buy that property. Collectibles would be another really bad one. Like if you have a bunch of money tied up into, rare vintage Star Wars action figures, they're worth a lot of money, but you need to find the right person that wants to pay what you want them to pay for them. Like it takes a while to sell those off. So collectibles can be bad investments that are not very liquid. Things like CDs. CDs usually have a time frame. You have to wait a year or 2 years or whatever until you can turn them into cash. So they can be not very liquid. Next thing to think about is risk. So investments don't always gain value. They can also lose value. You can buy a stock and the company can do well and you can gain value, or the company can do poorly and you can actually lose value. So we have to be careful and have to take that into consideration. We have to think about the risk. The probability that an investment will lose value is called its risk. Some investments, such as federally insured bank accounts, have really low risk. Something that's really good or safe would be like U.S. Treasury bills, your savings account, stuff like that. They are very safe. Your savings account, because they're federally backed. Basically, the U.S. government would have to collapse and stop paying back its debts before these things would not give you back your cash. So these things are very safe. They are very low risk. A bad example, something that has a lot of risk, would be like foreign stocks. So you can buy stocks from other countries. That can be really risky, especially if you go to countries that have maybe less stable governments, stuff like that. There's a lot more likelihood that your stocks will go up and down in price quicker. Might go down in price faster. Other things that might be bad examples for risk would be, just regular stocks. Foreign stocks are worse than just regular stocks, but regular stocks, collectibles, certain kind of collectibles can be really bad. It's like the Thai Beanie Babies back in the 90s. People were forking out tons of money for these rare Thai Beanie Babies because they decided they were worth so much. But then all of a sudden they were worth nothing. So some collectibles can actually go down in value when the collecting bubble bursts. They might look good for a little while, but it's just a fad. So risk something where it's going to lose value instead of gain value. Things like real estate are usually pretty safe. Will probably be pretty good as long as it's being taken care of. If you have a house that's disrepair, then maybe it's losing its value. But yeah, risk. Stocks are pretty risky. We're kind of worried about stocks. Bonds are usually on the safer side. They don't usually lose their value as easily as stocks, so they're usually a bit safer. Next one is return. This is the last one. Return. The growth of the value of investment is called its return. This can come from interest payments or growth in valuation, like the increase in the price of a stock. Usually, a higher return comes with a higher risk, which means there's a larger probability you'll lose some or all of your investment. So the riskier the investment, usually that's countered by a higher return. So people, like these U.S. Treasury bills, are really safe. They are very, very safe investments, but they pay really poor returns. They're a bad example because they don't pay very much interest. The idea being they are so safe that you don't really have to worry about your money getting lost. So you're willing to buy them even on a lower interest rate because you know that you will grow, your money will grow just because they will pay out. They're not a big worry. Same as your savings account. Most savings accounts pay really poor interest rates. They pay less than 1% a month. Really poor. But people like them because they're so safe. You don't have to worry about your money going away. A good example of return might be those foreign stocks. Because they're risky, they usually, if they do well, actually go up in price quite quickly. Another one would be what we call corporate or junk bonds. So these are bonds that are run by companies. There's a risk that a company might go bankrupt and never pay back your bond. So usually they have to put a lot higher interest rate on their bonds. So if you go and get a company bond, a corporate bond, not a government bond, so if I go to some organization, some company, and I buy a bond from them, they're going to have to give me a lot better coupon rate on that bond to entice me to buy their bond instead of going and buying the government bond, which is safer. It's a lot less likely that the U.S. government is going to default on their loans than it is just one company would default. So usually risk and return are kind of opposite. High risk usually means high return. Low risk usually means low return. And you kind of which risk you want. less, and with return you want more. So they're kind of, opposite. If one's good, the other one's kind of bad, and vice versa. Okay, let's look at stocks a little bit deeper. So historically, you can look at the stock market and you can see the general trend has been an upward trend. People have typically made money on the stock market. That's why so many people invest in stocks. Financial analysts like to use indexes that follow a whole group of different company stocks and kind of see how they're doing as a whole group. Some of those are the Dow Jones Industrial Average, the S&P Standard & Poor's 500, S&P 500, the NASDAQ. These are just a collection of stocks that someone's tracking where they have a little bit of all these different companies and they track and see how those are doing over a period of time. So here, this is the Dow Jones Industrial Average. And so they're looking at a collection of stocks that Dow Jones has picked out. And then, you can see back in 1900, they were already tracking this. They've been tracking it all the way. Here this chart goes through, probably almost 2020. And you can see over time, it has mostly gone up. There's been some dips. You can see like the 30s when we had the stock market crash that, really was a big crash. You can see why people were freaked out. It kind of climbed way too fast there and then all of a sudden just crashed. Back in 2008, we had a recession. So you can see that recession. That was kind of the housing crisis where people were loaning too much to people for houses they couldn't afford. So that was fun. There was a little downturn in the 80s. There was actually a little crash there. And there's been other little, downturns throughout. But in general, it climbs up. In fact, if you look at like 30, 40 years, you can't find a spot here where it didn't like double in value. So it's been generally an upward trend. And that's why people invest in stocks. Now, what people do is they invest in stock, they'll buy it, they'll hold on to it a certain amount of time, and then they'll sell it, hopefully at a higher price. And that's called the return. They managed to make some money off that stock. Now, we can look at that return in a couple different ways. The one is the total return, where you basically look at what percentage change there was in that stock. How much has it, was increased from when you first bought it to when you sold it, and how that much of a growth there was. We like to look at total return to see how much overall growth we had in the time we invested. But the one thing that's not great about total return is it doesn't reflect like the time frame. So if I have an investment over 5 years versus an investment over 10 years, if they have the same return, well, the 5-year investment is much better because it was a lot faster to get that same amount of growth. So a lot of people actually look at the annual return, which basically averages out this total return throughout the different years. And sadly, it can't just divide, the total amount by how many years, because we're not dealing with a linear growth situation. We're dealing with like exponential growth, this curve. And to find like the average, how much is it growing per year, we have to do a formula. So we got two formulas, one for total return, one for annual return. We'll use these whenever we buy and sell some kind of investment where we know the original price, and then we know the final sale price, and you can do annual if you know how much time it takes. So here's an example question with stocks. So we're going to do both the total and annual returns. They will specify, that's kind of a nice thing when you're doing this problem on the test, is someone will say total and annual returns, so you know you're looking for total and annual return. And they're labeled on the formula sheet, so I think it's pretty easy to figure out which one you're supposed to use. So here we're buying 50 shares of ABC stock for $40 a share. 3 years later, we're going to sell it, and we sold the stock for $3,900. No, that's not $3,900 per share. They didn't say that. That's just total price. A lot of these problems will do this where they might not give you the total price both times, but they give you enough information you can figure it out, right? So if I know I'm buying 50 shares at $40 a share, I could just multiply those and find out that was it $2,000 is the total price. Because when you do these formulas, you need your A and P. Your A, which would be your final amount, which in this case would be $3,900, and your P, your starting amount, which in this case would be $2,000, and your time, 3. You need these A and P to both be in the same kind of labels. Like I don't want, one to be per share and one to be for everything. So I made these both in the same amounts that are for everything, like 2,000 and 3,900 are for all the stocks. So now I can use those in the formula. So first, let's find our total return. So total return, I'm going to take A, which is 3,900, minus P, which is 2,000. And if you made profit, then this should be a positive number when you subtract these. If you got them backward and you get negative, that's a sign that you did it wrong, unless you lost money. It is possible to lose money on an investment. Maybe you sold it for less than you bought it for. But if you made profit on it, if you sold it for more than you bought it for, then this should be a positive. And you divide by P, but by number, not by A, but by P, so divide by 1,000. So I find the difference, how much it increased, and divide it by the original amount, the principal, and then multiply by 100 to turn it into a percent. If you don't multiply by 100, you just get in decimal form. So multiplying by 100 gives us the percent form. So we're going to type this in. Be careful, you do need parentheses on the top here so that the minus happens before the division. So I'm going to do parentheses, 3,900 minus 2,000. Close that parentheses, divide by 2,000, and then multiply by 100. And that gives me the percent. So there's a 95% growth on this one, so 95%. So that means I almost grew as much as I started with. So if I started with 2,000, if I would have had 100% growth, I would have increased up to $2,000. I'd be at 4,000 total. I went to 3,900, so I almost, earned as much as I started with, but not quite, because I didn't quite get to 4,000. So 95% growth. So for every dollar I invested, I made 95 cents, basically. That's 95%. Annual return is similar, but again, this is averaged out for the yearly rates. So we're going to use the time now, incorporate that, and figure out how much growth was there per year. Because this 95% is really impressive until someone else does the same thing in just 1 year. If they get 95% growth in 1 year, then their investment's way more impressive because we had 3 years to do ours. So this rate, this total return, it kind of depends on how long it takes. If it takes me 100 years to get 95%, that's not nearly as impressive as doing it in 3 years. Annual return takes this and makes it an average yearly amount. So I'm going to use this formula. Same A and P, that doesn't change. We still have the same starting amount, $2,000. The same final amount, 3,900. So we're going to put A, which is 3,900, over P, which is 2,000. Those are the same values we're using. Take to the power of 1 over time, which in this case is 3 years, minus 1, and then take that whole thing times 100 to get the percent. If you don't multiply by 100, you just don't get the percent, you get the decimal form. So that's why I have this. I put the times 100 in both on the formula sheet just to make it clear, we want the percentage for these. So 3,900 divided by 2,000, close that, do power, parentheses, 1 divided by 3, close that, get out of the power, so I can do my minus 1, close that parentheses, and times 100. There you go, so we got my 1/3, I got out of the power to do the minus 1, times 100, and this should give us our percent, which ends up being 24.93%. So you can see this is not what you get if you took 25 divided by 3. It doesn't work to just divide it by 3. Sadly, it's not that simple. Because here we're dealing with percentage growth where it's compounding each year, your annual return is going to be a little different than this number divided by 3. I can't just take 95 divided by 3. So total return, 95%. If each year for 3 years we've got 24% growth, because the first year we grew a little bit, the next year we grow even more, the next year we grow even more because it's compounding, it's building on itself, we would end up with 95% just by doing 24% each year. Almost 25%, I should say. So that's total return, annual return. Be ready for stocks to find total return, annual return. With bonds, notice that when we go to buy bonds, we don't always buy them from the original seller. So there is a secondary market for bonds, just like there's a stock market, there's a bond market. So maybe you might know someone that, or find someone that bought this $1,000 bond to help build the zoo in their city. And then they decide they want their cash fast. They don't want to wait till 5-10 years from now when the government is going to pay them back. So they say, well, I'll sell it right now, but because you're going to have to wait time to get your money back, maybe I'll have to sell it a little bit of a discount. So they might sell it for like $900, and so the person who buys it says, oh, I paid $900, and eventually I'm going to have $1,000 when this bond pays out its original value. So that's a great investment for them. And the other person has a $900 now they can start using for other investments. Yeah, they lost $100 they would have gotten in 5-10 years, but they think maybe they can make investments now that will make it worth it. So a lot of times you'll buy them on a secondary bond market and you've got a different price. Now, if you pay a different price, then that coupon rate, that interest rate, doesn't really work for you anymore because the coupon rate was the interest rate based on the original price of the bond. If I had a 10% interest rate on that $1,000 bond, that means that I would make $100 per year. But if I go pay $900 for it, I'm not really making 10% anymore. I'm making better than that because I'm still making $100, but I only paid $900. So we need a better interest rate. We need a different interest rate that actually reflects the new price we paid for it. We call this interest rate the current yield. So the current yield is basically the interest you're getting based on the price you paid. When you pay exactly the original cost, the current yield is going to be the same as the coupon rate. But if you get the bond at a discount, the current yield is going to be higher. And it's going to reflect the fact that you bought this at a discount and you're making better interest payments. If you did end up paying an extra for a bond, if you paid more than the original price, your current yield would be low because you paid too much for the bond, so now your interest payments wouldn't be as good. So the formula for current yield is AIP, which is just a fancy way of saying annual interest payment. So how much does it pay in interest per year? Remember that bonds pay simple interest. So when we're doing stuff for bonds, you always have to think about simple interest. We get so caught up in doing compound interest. Remember that bonds pay simple interest. And then price, when I talk about the price, we're not talking about the original price because that would just give you coupon rate. They want the current price. So this is going to be the current, like market value, how much it's going for right now. So let's look at a problem. We want to find the current yield. So we're going to find the current yield on a bond. Originally it went for $1,000. So it was a $1,000 treasury bond. Its coupon rate is 6%. That's its interest rate based on that original $1,000. And it has a market value of $750. We need to figure out its current interest rate, which is probably going to be a little bit higher than 6% because we got it at a discount, right? We are buying it for $750, which is less than the original $1,000 price. To figure out this current yield, first we need to figure out how much interest is it paying in a year. So we're going to go back and first we're going to figure out its interest. We're using simple interest. So the formula for simple interest, we have the final amount is worth the principal times 1 plus the APR times the time. Now we want just 1 year, so we're going to make time equals 1 because we want annual. So this is where time is going to be 1 because we're doing just 1 year's interest. We want to find out what 1 year's interest is. So we'll use this formula with t equals 1. The interest rate is 6%. That's our APR in this case. Now, because we're dealing with the APR, the coupon rate, remember, always goes with the original price. We don't calculate coupon rate on the market value. That wouldn't make any sense. The coupon rate is the interest rate is going to pay based on the original price. So in this case, our principal will be $1,000. So using that information, we can figure out what it's going to pay per month. So first off, we'll do $1,000 for principal, 1 plus the APR, which is 0.06. And we just want 1 year, so we're going to put 1 in for time. And that'll tell us how much it's worth at the end of the year. So $1,000 times parentheses 1 plus 0.06 times 1. Now that gives us 1060, but that's actually the total, right? That's the original principal plus the interest. So we do need to take away that original principal to get the interest, and that is going to be our AIP. So to find AIP, to find 1 year's interest, we use that 6% of the face value. This is your face value. Because coupon rates always go with face value. So coupon rates go with face value. So that gives us the interest payment. Now that we know the interest payment, we can find current yield by taking that annual interest payment, $60, and dividing it by the current price. We're not looking at the original price, we're looking at the market value, the current price. We're going to divide by 750. If you divide it by 1,000, you'd actually go back to 60%, which would be the coupon rate. And that would tell you you're doing it wrong because we know that the current yield should always be higher when you're buying it at a discount. So you know you're doing it right if you say, okay, I bought it on sale, my current yield should be higher than my original coupon rate. So divide 60 over 750. This does give us the value in decimal. So I'm going to take this and divide, you get a decimal, which is 0.08. This is 0.08, which turns into 8%. So you can see, because we got this at a nice discount, $250 off, we are actually better at making 8% interest instead of making 10%. This is what's, the people advertise on this bond is they'll say, instead of telling you the coupon rate, they'll probably actually tell you the current rate yield when they sell it to you. And people will look at that because that's what they want to know. Like, based on how much I'm paying now, am I making good interest off this? And well, the higher the current yield is, the better your interest is. Yes, also you're going to make extra money because when they pay you back, at the end they can pay back the $1,000. They always pay back the face value on a bond. So when you get to maturity date, not only have you gotten all this interest payments leading up to it, that maturity date, you're going to get $1,000 from that bond. So you make a good amount of money. That's why people like to buy these bonds on the secondhand market at a little bit of a discount and try and make some extra money on. So let's do one more. But this one we're going to do a little bit backwards. So here, instead of trying to find current yield, we actually have the current yield. Like I said, a lot of times people will publish that. They'll say, here's the current yield of the bond. But we want to know what the actual annual interest payment is, because they told us the current yield, but they haven't told us exactly how much it pays per month or per year. So we're going to use the same formula here. We use the current yield formula, but now we know the current yield. We know the current price of the bond. We want to go back and find the annual interest payment. So solving for AIP. Okay, so we want to find the annual interest, calculate the annual interest on a bond that's described below. And it says a $800 treasury bond, so that's the original price, that's the face value. Current yield of 3.6%, so that's our current yield. Remember, that's the interest rate that goes with the current price, not with the original face value price. So we can't use this 3.6 with the 800, because that's the face value. That would go with coupon rate. This is for the current price. Here they actually don't tell you the price. What they tell you is that it's quoted at 105 points. And what is going on with that? Well, a lot of times when people go to buy bonds, you have these big investors working for big companies. They might have millions or billions of dollars. And so they don't really want to look at each bond individually as like, here's a $1,000 bond, here's a $500 bond, here's a $750 bond. It's better for them to look at a bond and say, is it overvalued or undervalued? Is it selling at a discount or is it selling above its price? If it's selling at a discount, the percentage of its value would be less than 100, and these points are basically the percentage of value. So if you get a number that's below 100, it's on sale, and it's on be a better deal. If it's above 100, it's actually a little overpriced. It's priced higher than it originally was, and so you actually have to pay a little bit extra for it. So like in this case, 3.6% current yield. This is going to be a little bit lower than the coupon rate because this bond is actually being overpriced. So we can find the actual price using this 105 points because this is 105% of the face value. That's what it's selling for right now. So its value now is 105% of the face value. So we can take the face value, $800, that's the face value, and multiply it by 1.05. That's the decimal version of 105%. And that'll tell us the current price. Like I said, because a lot of big bond investors don't need to know these little details like what's the current price, stuff like that. They just want to know, how, is this bond doing better or worse when they go look through the market, and then they find all the ones that are, on sale discount. They snatch those up first if they can. So that's why they advertise it this way with the points. Okay, because it was overpriced, it's actually selling for $840. This is the current price because that's at 105 points. You can always find the market value, the current price, if you take the face value times the number of points. And that'll give you the current price. Now we know the current price is $840. We know the current yield is 3.6%. We can go back and find what the annual interest payment is. So using the current yield formula of our current yield, which is 0.036, that's current yield in decimal form, equals price is $840, and then AIP is what we're trying to sell for. So we can just multiply both sides by 840. Cancel that, and we'll get the AIP. So just multiply 840 times 0.036, and it tells us that our annual interest payment is actually $30.24. That's the annual interest payment. Now we know how much we're paying in interest each year. We're gaining. We get $30 interest payment every year. We actually never found the coupon rate, so we don't know what the coupon rate is. You could take this and divide it by 800, and that would tell you what the coupon rate is, because the percentage of that, and that would give us the coupon rate. But we just needed to know the annual interest payment. And we found it, again, we used that current yield formula. We just worked backwards. We found the current price, and then we put in the current yield and the current price, and then work backwards to find the annual interest payment. And that's how bonds work. Again, remember, bonds are paying simple interest. So it's not compounding each year. You don't get like $30 this year and then like $31 next year. You just get $30 each year, and that's how they work. Okay, last page, just want to talk a little bit about mutual funds. So a lot of times when people invest, they don't invest directly, don't go out and buy all the different shares of stocks and bonds and stuff. It takes a lot of time and effort, maybe a little bit of money to research and figure out which stocks and bonds are worth buying and which are not. So a lot of people rely on someone else to do that for them. This is called making an indirect investment. You have someone else kind of purchasing for you. And one of the main ways people do that is through a mutual fund. So mutual funds are also stolen shares, just like stocks, but they're actually a collection of stocks or bonds or both. So you can buy a mutual fund that's all stocks, you can buy one that's all bonds, you can buy one that's a mix of the two. So a mutual fund has a manager, a fund manager, who makes their money off a little percentage of, how much they have invested with them. And then they take all this other people's money and they invest and they buy certain stocks and bonds according to their plan. They actually have to lay it out. There's paperwork kind of showing what the plan is. To keep fees down, people now a lot of times have computers do these. So it used to be you'd hire a fund manager. You could still do this. You'd hire a fund manager for your mutual fund, and then you find $5 billion worth of assets between all these people. They put all their money in there, and then that mutual fund manager gets paid like 1/10 of 1% of all the profits on those $5 billion assets. But that still means they make like $500,000 a year or something like that, because those are all growing with interest and stuff if he's investing them well. So that's where he makes his money, is on the growth. And then all the people just rely on him to invest it well. But what we kind of found for long-term investing, a lot of times the fund managers can actually be bad because they react to trends in the market a little too much. So now a lot of people will have a computer just follow one of like the big averages, like the Dow Jones Industrial Average or the S&P 500, and they'll just kind of keep a nice balanced portfolio collection of stocks and bonds that follow those big markets, not just stocks. And they'll just invest in those with all the money they have. That's called an index fund, where you have a fund that tracks a market like the Dow Jones or the S&P 500. Another way people have worked with mutual funds to invest is with what's called the target fund. So a target fund is designed specifically for retirement. This is a mix of stock and bond investments. The fund begins with higher risk investments. So the idea is when you first buy it, when you're younger, you have a long time until you're going to retire, and you can buy a lot of stock investments. And stocks are risky, they can go up or down, but in general they have higher returns. So it's kind of nice to be in this risky investment with higher returns. When you're young, you can take a little bit of risk, you still have plenty of time to grow your retirement. And then as you get closer to retirement, they actually switch over more to bonds. And bonds are safer. When you're getting closer to retirement, you're not as willing to lose the way you already gained in investments. So then bonds are a little bit safer to invest in. These funds, begin with high risk, move slowly to safer. When you get real close to the target date, they basically sell off even the stocks and bonds and kind of move into just like cash investments, things that are really, really safe. I actually use these for my retirement. This is something I've read about a little bit, and I think they're a pretty good idea. Something where you can be risky when you're younger, and then as you get closer to being older, you don't want to risk, the stock market crashing right before you're ready to retire. Tax sheltering, it sounds like something that should be illegal, but it's not. Tax sheltering is actually something that the government supports and encourages. What this is when you invest in things like an IRA, 401k, HSA. I put that backwards. That's supposed to say HSA. There's a typo there. HSA, Health Savings Account, not HAS. These things you can invest in with pre-tax money, which means the money you put into them doesn't get taxed. It actually lowers your income bracket, so that when you calculate your taxes, you look like you make less money, so that you pay less taxes. And since the money was taken out pre-tax, then you have more money to put in the bank account to grow into a good retirement fund. But it's because you're able to take advantage of this tax sheltering. And so it allows you to invest your current taxable income and lower your current taxable income. And then when you go to retire, yeah, you're paying taxes on those investments when you retire, but usually most people are making less money in retirement than they are when they're working full time. So it's not as big a deal to pay taxes on it then as it would be if you paid taxes on it now. So you basically are shifting your tax burden from, hey, when I'm young and working hard and making lots of money, let's take some of that money and not pay taxes on it until I'm old and I'm retired and I'm not working all the time. There are other types of tax sheltering. There are Roth IRAs where basically it does the opposite. It says, I think I'm going to have so much in savings for retirement that I can actually pay the taxes now and then not have to pay the taxes later. But that's for specifically people that think they'll pay, they'll be in a higher income bracket when they go to retire than they are now. So Roth IRAs are for special situations. But yeah, mutual funds usually can be used for all these, different types of tax sheltering and of investing. Basically lets you take these investments that maybe you would avoid taxes and invest them in stocks and bonds and groups of them instead of just like one stock and one company, which can be kind of dangerous because you never know when one company is going to have a bad year or a bad time. They might go bankrupt. You might lose all your money in that. Hopefully this gives you a little bit better understanding about how people invest and what investing is. Next time, we'll get into loans, especially into mortgages, a little bit more how those work, how we pay those off, how we calculate those. So that's next time. I'll see you then.